Hi everyone, welcome to the Sustainability video series. I'm Vahideh, a PhD student in the University of Bonn. In the last video, we introduced you 12 principles of the green chemistry as a guideline for the sustainability. For the most of the reactions to happen, we need a medium which called solvents. The most famous solvents is water, but sometimes we need to have the other solvents to fulfill the principle number 5 of the green chemistry principles. This new class of the solvents should be benign, renewable, green, and sustainable. One of the class of the solvents for this purpose could be ionic liquids. But what are the ionic liquids and how they can be applied will explain by Jan.
Thank you, Vahideh. Hi everyone. On a very basic level, we can consider ionic liquids just as molten salts. An ionic liquid might look something like this. It's a lightly colored, maybe even clear substance, and it is a little bit syrupy. Ionic liquids feature very interesting properties which are relevant for the 5th principle of green chemistry and for sustainability. They are, for instance, non-flammable and do not expose harmful vapor to the environment. On top of that, they can be easily recycled and reused, which reduces the production of chemical waste. Nowadays, ionic liquids are already used in many sustainable applications, like for instance in solar cells, batteries or in fuel cells. However, there is a key problem to ionic liquids because there exist millions and millions of different ones and they all have different chemical properties. The key question for us is, how can we find the right ionic liquid that fits an application that we are interested in? We are now here at the Mulliken Center for Theoretical Chemistry. As theoretical or computational chemists, we develop software and apply it to study chemical problems or questions. In the group of Professor Barbara Kirschner, one of our main topics is the investigation of ionic liquids with such computer programs. By this we want to learn how ionic liquids work in different applications and try to design new ionic liquids which are more sustainable and work more efficient. Follow me. One example is the design of ionic liquids which can remove carbon dioxide from the environment. The design of such ionic liquids has a great potential to decrease our human-made carbon dioxide footprint. To study CO2 absorption by an ionic liquid, we can use computer simulations like the one you can see here. On the right and bottom you can see the ionic liquid and on the left-hand side the carbon dioxide. If now the carbon dioxide binds to the ionic liquid, it can be removed from the environment. By studying this reaction, we can then learn which properties make an ionic liquid a good candidate for carbon dioxide capture. With this information, we can then propose new ways to capture carbon dioxide, where we replace harmful solvents with ionic liquids in order to comply with the 5th principle of green chemistry.
Thanks, Jan. As you've seen in this video, chemistry is not restricted to the lab. We are able to deal with the chemical problems and design new solvents by applying computers and the softwares. In the next video, we will move to the lab to see how chemists in the University of Bonn dealing with the chemistry in the research area. Please don't forget to leave in the comments. Bye bye, see you in the next video.